Hello and welcome to my presentation on graphical inference with convolutional neural networks. So first off, to describe the goal of this project, I just wanted to first off assist and accelerate the exploratory data analysis process, especially when we have a number of different features and it becomes difficult to individually inspect all of the different patterns we have. And second, to be able to separate noise from an actual pattern in a lineup of images. When, say, we have 10 images that are just noise or very noisy versions of a pattern and one real pattern, can we pick out that pattern effectively? So first off, I just had to generate a bunch of data because I quickly realized it would be too difficult to use known data sets and create scatter plots that way. So I came up with 14 different classes, 14 different functions with a number of different ways to add noise and a little bit of randomness and variance to them, whether that meant choosing a random slope or just simply adding a bit of extra noisiness to it, and use that to create 300 different data sets for each generation function, to then be converted into images using alpha holes, as was previously suggested in a different format in a scagnostics or scatterplot diagnostics paper a while back. Alpha holes are essentially just what you get when you try and roll a wheel around your data set with a certain diameter that's defined by an alpha value. I then converted all the images to 20 dpi in order to reduce their complexity and later on speed up the training process. Now, one thing to note is that the alpha value I chose to fit each hole to each data set was random within a set of alpha values. So when choosing a random alpha value, you can get a number of different potentially poorly fit holes, or in some cases ambiguous but not poorly fit holes that simply look like they could belong to one or more classes, especially in the cases where two classes are slightly similar to one another and there's a lot of noise involved. Or we can also have holes that are simply poorly fit, as you can see below, where we have an overall linear trend, but an alpha value that was too high was chosen, so an outlier that shouldn't have been included and shouldn't have affected the hole altered its shape. Now, I then used a convolutional neural network in order to train a classifier that would be able to distinguish the 14 different classes from one another based on the images that I generated. Now, convolutional neural networks are very well known in image recognition, so I essentially created an image recognition classifier in order to recognize the holes. Now, as far as the actual architecture, I have 4 convolutional / pooling layers. That's to say I have a convolutional layer and then a pooling layer back to back. And then I have 3 dropout layers interspersed within those convo pooling layers. And finally, a softmax activation function to output the final classes. Now, as far as results, the classifier appeared to perform fairly well, with the CNN getting average precision recall and F1 scores above 0.9 on the 14 different classes, and precision recall and F1 scores well above 0.9 when working on a simplified version of the question where it simply has to distinguish noise from signal or noise from a nonlinear signal. I also went and hand-labeled a data set of a very famous abalone data set, and the CNN performed quite admirably on that as well, receiving 0.72 accuracy, and I should note that 0.72 accuracy is a very conservative estimate of its accuracy because in the case of any sort of ambiguity or tie, I always labeled that as a failure. So overall, I think the method performed quite well, and just by playing around with it on my own, I've seen good results overall. Sorry for the rush. I hope if you have any questions, you'll send them my way. And I hope you enjoyed the presentation overall. Thank you.